All right. We're going to start 2 days focusing on intercept form. This is the first note catcher that we're going to work on. This is about taking intercept form from a function and creating a graph, being able to identify the characteristics and graph it on an XY plane. Last class, we did an exploration where we found some very important stuff. We found that if we have our quadratic written like this, oops, I didn't quite get all of it. If we have our quadratic written like this as 2 groups with an x and some number, we can actually pull out our intercepts looking at these numbers. And we found that it was actually always going to be the opposite. And so in fact, in the form, we put a negative, we put a subtraction sign. And we'll see how that works in just a little bit. What we also verified was we verified that A still controls the curve. So A still controls the curve. If it's positive, it curves up. If it's negative, it curves down. It'll also control shrink and stretch. It'll shrink if A is greater than 1, and it will stretch if A is less than 1. So A is actually doing the same thing in intercept form as it did in vertex form and standard form. So A is kind of a neat variable in that it does the same thing no matter what form we're in. P and Q are the new ones to intercept form. These are just our x-intercepts. Both P and Q will be our 2 x-intercepts. And like we saw in the form, these are going to be the opposite of whatever the sign is in the function. So if it's subtract P, that means that P is a positive. If it's plus P, that means that P was a negative. Our axis of symmetry we were able to find as the point between P and Q. It's exactly halfway between P and Q, those 2 x-intercepts. Now mathematically, if you wanted to find that, if you weren't sure visually just by looking at it, you could do P plus Q divided by 2, and that'll find you the average of those 2 numbers, or the axis of symmetry. It'll find you that point between. The vertex is going to be directly between them, so we're actually going to be able to find that H, find the axis of symmetry, and plug that in. So we can plug in the axis of symmetry, which we're calling H, into the function for x. And the y that comes out will give us the other part of our vertex in H, K format. And then y-intercept, this final part, well, all of our y-intercepts are just whenever x equals 0, so we can plug that in to the function and see what happens. So let's see an example of if we're given a function in intercept form, how can we pull these pieces of information off? Remember, this is x minus p and x minus q with an a out front potentially. Here, a is just going to be 1. So this shouldn't have any stretch or shrink. It's a positive one, so it should curve up. These are the things that we know. It'll curve up, and it won't have much of a stretch or a shrink. So let's see, x-intercepts. We've got p. P is 5, because we have x minus p, x minus 5, so that tells me p is 5. So one of my x-intercepts will be 5, 0. Now the other one, we've got x plus 1, which means that my q was actually -1, because this sign changed. So we're actually going to have -1, 0. So there are our 2 x-intercepts, and we can put those on the graph. Now, axis of symmetry, we could count in between them. In fact, here it's really easy to do because we've got nice whole integers that are equidistant, even number between them. So we know that it's 3 to the left and 3 to the right. So we actually know right away, but just by visually looking, that our axis of symmetry is when x equals 2. If we wanted to double check, we could do p plus q, so 5 plus -1 divided by 2, and that's going to be 4/2 or 2. So that's a good way to double check. We're good. Let's check out the vertex. Now the vertex is going to exist on that axis of symmetry, so we can plug in 2 for the function. So if the function is being plugged into, and we have, let's see, x minus 5, so we're going to do 2 minus 5. And same thing, we've got x plus 1, so we're going to do 2 plus 1. Let's see what we get out. Let's see. We have 2 minus 5, which is minus 3. We have 2 plus 1, which is positive 3. And so those two things multiplied is going to get me negative 9. So my vertex is at 2, negative 9. And I can even throw that on the graph up here as well. Now, looking for my y-intercept, we know that we're just going to plug in 0 into the function. So we're just going to do the function at 0. That's going to be 0 minus 5, just plugging 0 in for x now. And we'll find negative 5 and 1. And so your answer will be negative 5. So this will be 0, negative 5. And let's put that on there too. Let's put that y-intercept on there. And of course, it's always good to come back to our graph and just kind of like make sure that what we're seeing is making sense. We could mirror the y-intercept because it's 2 from the axis of intercept. We can go 2 units the other way, put a point on there. And now we can draw a nice curve, kind of down through, back up, like that, making sure to put our arrows on there to indicate it keeps going on and on. And this looks pretty good. I don't see much of a stretch or shrink, which is what I expected. I also see it curving up, which is what I expected. So intercept form is actually really handy. Doesn't take too many calculations, but we can get a good visual right away. So let's do one more example. If you feel good about this, feel free to start the practice worksheet right now, but I'm going to do one more example for anybody who wants to see one. So again, turn this off, go do the practice if you're feeling good. If you want to see another one, stick around just for one more example. Here again, we have a, we've got x minus p, and we have x minus q. Let's see, intercepts. If you've got x minus p and we see a positive 4, that tells me that one of them was negative 4. Because again, we're going to do the opposite of what we're seeing there. Same thing, if we've got positive 8, that tells me it was negative 8. So there are my two intercepts. Right there, right there. I can see my axis of symmetry already. Visually, it's right there, right between those 2 points. So that is at negative 6. If I wanted to double check, I'm going to do negative 4 plus negative 8 divided by 2. And I'll find negative 12 divided by 2. And of course, that's negative 6. So we're good. We double checked. Scrolling down just a little bit. We're going to do our vertex next. So we're going to do the function. And we're just plugging in the axis of symmetry. So we're going to do negative 6 here. And wherever we see x, we're going to plug in that negative 6. So negative 6 plus 4. And again, negative 6 plus 8. Let's just simplify this. We got negative 2 times, let's see, negative 6 plus 4 is negative 2. Negative 6 plus 8, that is positive 2. Negative 2 times negative 2 is 4. And 4 times 2 is 8. Okay. So our vertex was at negative 6. The y value is 8. And we can throw that on our graph up here, negative 6 and positive 8. This is making sense so far because we see a negative a value in this one, so the curve should be down. So we're actually going to see a curve go down through these points and kind of go down forever and ever and ever and ever. Now it looks like our y-intercept is going to be off the graph because this is a little bit narrower because we have an a value over 1. Let's just double check and see if that's what we get when we plug in 0. So if we're looking for the function, when we plug in 0 for x, we're just going to plug in 0 wherever we saw x. Just like that. we get -2 times 4 times 8. -2 times 4 is -8. And 8, well, that's like -64. So yes, comfortably off the graph, way down in that negative direction. So it's exactly what we thought it would be. All right. Work on that practice worksheet. You've got the rest of class to do that. If you don't finish it in class, it will become homework. So please use your time wisely. If you finish early, just work on any missing homework or your cheat sheet for the upcoming tests. All right, have a good day.